Let's take a look at product to sum and sum to product formulas. And that's not the right one. Doesn't look like I have it up and running. Okay. Product sum product. Here it is. Well, we got our formulas here where we are rewriting the multiplication with plus minus. So sine alpha times sine beta is equal to 1/2 cosine alpha minus beta minus cosine alpha plus beta. And cosine alpha cosine beta is equal to 1/2 cosine alpha minus beta plus cosine alpha plus beta. And sine alpha cosine beta is equal to 1/2 times sine alpha plus beta plus sine alpha minus beta. And then going the other direction, we're going from addition, subtraction, rewriting as multiplication. So sine alpha plus sine beta is equal to 2 sine alpha plus beta all over 2 times cosine alpha minus beta all over 2. Sine alpha minus sine beta is equal to 2 sine alpha minus beta all over 2 cosine alpha plus beta over 2. And cosine alpha plus cosine beta is equal to 2 cosine alpha plus beta over 2 times cosine alpha minus beta over 2. And cosine alpha minus cosine beta is equal to negative 2 sine alpha plus beta over 2 times sine alpha minus beta over 2. Now these formulas, again here, that we'll be looking at in the problems really, you don't run across them that much. They're more to give you some practice getting used to these formulas, so that when you run across them in calculus, or maybe, I'm not sure about engineering physics, but maybe in those classes that you know how to apply them. Well, let's take a look at our first problem. We got cosine of 112.5 degrees times cosine of 22.5 degrees. And it says find the exact value of each expression. Okay, so let's go over to our formulas. We're looking for cosine of something times cosine of something. Cosine of something times cosine of something, that's formula 2. So our formula says cosine alpha times cosine beta is equal to 1/2 times cosine of alpha minus beta plus cosine of alpha plus beta. Since my eyes cross, I'm going to look at this a few times here to make sure I got everything correct. That looks right. Okay, so here's our formula. Well, this will be our alpha, and this would be our beta. So just plugging them into our formula, this part right here becomes 1/2 times cosine of alpha, which is 112.5 degrees, minus beta, which is 22.5 degrees, and then plus cosine of alpha, which is 112.5 degrees, plus beta, 22.5 degrees. Is that 90 degrees? Let's see. Yeah, 90 degrees. 112.5 minus 22.5 is 90. And over here, that gives us 135. So 135 degrees. Well, if I look on our unit circle, cosine of 90 degrees, cosine is our x. Cosine will be 0. At 135, cosine is going to equal to a negative square root of 2 over 2. Somewhere I got the unit circle. There it is. Okay. So again, cosine 90 degrees, cosine is our x, so 0. Cosine 135 is over here. And that's our x, which is negative square root of 2 over 2. Well, 0 drops away. Multiply these together, we get negative square root of 2 over 4. And that'd be our answer. Let's look at our second problem here. We got sine of 7 pi over 12 minus sine of pi over 12. It says find the exact value of each expression. So again, I'm looking at my formulas. I'm looking for sine of something minus sine of something. Sine of something minus sine of something. That looks like the fifth one we have here. So let me write down that formula. Sine alpha minus sine beta is equal to 2 sine alpha minus beta over 2 cosine alpha plus beta over 2. And I'm going to double check this real carefully because my eyes do cross. That looks right. Well, this would be our alpha here, and this would be our beta. So we just plug them into our formula. So we're going to have 2 sine alpha, so 7 pi over 12, minus beta, which is pi over 12, all over 2. And then we'll have cosine of 7 pi over 12 plus pi over 12, all over 2. Well, 7 pi over 12 minus 1 pi over 12 is 6 pi over 12 over 2. 7 pi over 12 plus 1 pi over 12 is 8 pi over 12 all over 2, which gives us pi over 2. 6 and 12 both divisible by 6 over 2. And this would give us 2 pi over 3 over 2. Now, if you have a single fraction up on top, you can take that denominator, like this 2 here, and put it down with the denominator down here. So this will become 2 sine pi over 4 cosine, and this will become 2 pi over 3 times 2 would give us 6. So this becomes 2 sine pi over 4 cosine of pi over 3. And that reduces. Well, at pi over 4, sine is equal to square root of 2 over 2. Cosine of pi over 3 is equal to 1/2. And again, just look at those up in unit circle. Sine pi over 4, here's pi over 4, sine is our y, so square root of 2 over 2. Cosine pi over 3, here's pi over 3, cosine is our x, which is 1/2. Okay, well that 2 cancels with one of these 2's, so then we're left with square root of 2 over 2 as our answer. Let me save this. Product to sum and sum to product. And this would be page 01.pdf. There we go. And let's look at our next problem. Let's see, got cosine of 6 theta, cosine of 2 theta. Some of these we're using in Calc 2 now. These come in handy, these formulas. It says express each product as a sum containing only sines or only cosines. So we got cosine of something times cosine of something. So let's go look at our formulas. cosine of something times cosine of something, that's formula 2. So we got cosine of alpha times cosine of beta is equal to 1/2 times cosine of alpha minus beta plus cosine of alpha plus beta. Double check that. Alpha minus beta plus, yep, that looks right. Okay, so this formula right here, this would be our alpha, and this would be our beta. So this would become 1/2 times cosine of alpha minus beta. So we got 6 theta minus 2 theta plus cosine of alpha plus beta. So 6 theta plus 2 theta. Well, 6 theta minus 2 theta gives us 4 theta. And over here, 6 theta plus 2 theta gives us 8 theta. And we just accomplished what they're asking. Express each product as a sum containing only sines or only cosines. This only has cosines. So that'd be your answer. Let's look at our next problem. Let me grab a drink first. There we go. Okay, so we got sine 3 theta over 2 times cosine of 7 theta over 2. And same instructions, so we're going to look for a formula that's sine cosine. Sine cosine is our third one. So let's write that down. Sine alpha cosine beta is equal to 1/2 sine alpha plus beta. Why do I keep doing that? Okay. Plus sine of alpha minus beta. We double check that. Sine alpha cosine beta, 1/2 sine alpha plus beta plus sine. That looks good. Okay. Well, this would be our alpha, and this would be our beta. So from our formula, this becomes 1/2 sine alpha plus beta. So we got 3 theta over 2 plus 7 theta over 2 plus sine of alpha minus beta. So we got 3 theta over 2 minus 7 theta over 2. Well, 3 theta plus 7 theta is 10 theta over 2. 3 theta minus 7 theta is negative 4 theta over 2. Well, 5 divided by 2 gives us 5 theta. And negative, remember, you can put out in front because it's an odd function. And then 4 divided by 2 gives us 2 theta. And that's what we're hoping to accomplish. Typically, you don't leave a negative inside of a trig function. Save that. Let's look at our next problem. Got sine 6 theta plus sine 2 theta. probably want us to write as a product. Express each sum or difference as a product of sines and or cosines. Okay, so let's go look at our formulas. We're looking for sine of something plus sine of something. Sine of something plus sine of something looks like formula 4. So sine alpha plus sine beta is equal to 2 sine alpha plus beta over 2 times cosine alpha minus beta over 2. Now let me double check that. Sine of alpha plus beta, okay, equals 2 sine alpha plus beta cosine alpha minus beta. Okay, that looks right. Well, this is going to be our alpha, and this will be our beta. So from our formula, this becomes 2 sine alpha plus beta. So I got 6 theta plus 2 theta divided by 2. Cosine alpha minus beta. So we got 6 theta minus 2 theta over 2. Well, 6 theta plus 2 theta is 8 theta. Divided by 2 gives us 4 theta. And 6 theta minus 2 theta is 4 theta. Divided by 2 is 2 theta. And that's what they're wanting. Okay, let's look at our next problem. It says establish the identity. Again, you're not going to be sitting there doing identities right and left. The main goal here is to get very comfortable with these formulas. So we got cosine of 3x plus cosine of x over sine of 3x minus sine x equals cotangent x. Well, I'm going to start with the left side, and we're going to use our formulas. So I'm looking for cosine of something plus cosine of something. Cosine of something plus cosine of something is number 6. So I'm going to rewrite top using number 6. And sine of something minus sine of something. Sine of something minus sine of something. That'd be number 5. So rewrite the bottom is number 5. Okay, so back to the top. Number 6, we got alpha and beta. So this would be alpha, and this would be beta. And on the bottom here, this is going to be alpha, and that'll be beta in a different formula. Okay. So property 6 says 2 cosine. So 2 cosine alpha plus beta. So I got 3x plus x over 2. And then cosine alpha minus beta. So cosine of 3x minus x over 2. Our bottom one is formula 5. So we got 2 sine alpha minus beta. So we got 3x minus x over 2. And cosine alpha plus beta. So cosine of 3x plus x over 2. Well, 2's cancel right away. Cosine 3x plus x over 2, cosine 3x plus x over 2, those are going to go away. So up on top here, we're left with cosine 3x minus x is 2x over 2, gives us cosine x. And down here, we got sine of 3x minus x, which is 2x. 2x divided by 2 is x. So this is sine x. And cosine over sine gives us cotangent. So we verified that identity. Let me start a new one. I'm not sure how much space this will take. I worked it already in class, but I don't remember. Okay, so let's look at our last problem here. We got sine of 5x plus sine of 3x is equal to 0. And solve each equation on the interval from 0 to 2 pi. Well, I'm looking for a formula that's sine of something plus sine of something, which would be 4. So I'm using formula 4. And this would be our alpha, and this would be our beta. So, from formula 4 becomes 2 sine alpha plus beta. So we got 5x plus 3x over 2. And then cosine alpha minus beta. So cosine of 5x minus 3x over 2 equals 0. Now let me double check myself there. 2 sine, add those, and then subtract those. Okay. 5x plus 3x is 8x, divided by 2 is 4x. And 5x minus 3x is 2x, divided by 2 gives us x equal to 0. Now, we got 0 on one side, we factored the other side, we'll set each factor equal to 0. Now, I won't set the 2 equal to 0, but set the sine 4x equal to 0, and cosine x equals 0. Now, cosine is our x part, which is pi over 2 and 3 pi over 2. Oh. Now for sine, I'm going to do this kind of our old style. Okay, I look at where sine something is equal to 0. Well, sine is our y part, so 0, it's equal to 0. We also look at the next one, pi. It's equal to 0. Next one would be 2 pi. It's also equal to 0. Next one would be 3 pi. Next one would be 4 pi. Like that. Now, that's me enough to see a pattern. Now, these aren't our answers, because this is 4x. So what I do is I set this 4x equal to 0. So I'll say 4x is equal to 0 and solve this, and we get x equals 0. On this one, I'm going to take the 4x and set it equal to pi. Well, when I do that, I get 4x is equal to pi, or x is equal to pi over 4. This one here, I'll set the 4x equal to the 2 pi. So I got 4x equals 2 pi. Divide both sides by 4, and we get 2 pi over 4, or pi halves. You see a pattern now, don't you? 0, pi over 4, 3, or 0, pi over 4, 2 pi over 4. This will be 3 pi over 4, if I looked at it. Next one would be 4 pi over 4, which is the same as pi. Next one is 5 pi over 4. Next one is 6 pi over 4, which is 3 pi over 2. And then 7 pi over 4. Now, we're not including 2 pi, so we don't go to 8 pi over 4. Now, remember, when you have a sine or a cosine and you got a number in front of the x like that, like 4, you take that 4, you double it, that's how many answers you can have. And you see we have 8 answers here. Now, some of them we already wrote down, or at least one, actually 2 of them. We already wrote down pi over 2 and 3 pi over 2, so we don't have to write those down again. That wouldn't be there, and that wouldn't be there. So those are our 8 answers, what I got circled still. And let me save that. And stop the recorder. And stop the other recorder.